In the last video, we talked about how to get the initial positions of your balls and of the finish line. You have a record of that. Now it's time to move on to velocity. So let's get our data table. So here's our video, of course, where we're going to get it. Actually, let me go ahead and set up. We're going to need our meter stick. And we're going to do the white ball first because it's not the top. And you say, well, I thought the meter stick goes back here. Well, now that we have the initial position set, we can now move our meter stick whatever's more convenient. And it's more convenient to take position data to get velocity if we just start at 0. I also need my stopwatch, and there we go. So, and actually here's our first, let me just set where I want it. All right, so here's our first data point for the white ball. I'm going to say at 0 seconds, it's at a position of, and the right edge there is at 0 centimeters. So I'm going to record that in the data table under part 2. Now I need to get that data table set up, which I haven't done yet. So left column is going to be time, and the right column is going to be position on the x-axis. All right, so here is time, and the units are going to be seconds, and the variable is t for time. And the next column is position on the x-axis. And I see that the meter stick is in centimeters, and the variable is going to be x for position on the x-axis. All right, now here's my first data point. At 0 seconds, it was at a position of 0 centimeters. Now let me go ahead and finish the time here, because I'm going to take it in increments of 0.2 seconds. Now, it may end up that I don't have enough time. I can't remember now, but I can always make adjustments here. So every 0.2 of a second. And where did I come up with that? Well, I'm estimating we have about a second of time. And, you know, so it just seems reasonable to me. I wouldn't want to make it like 0.001 seconds apart. So anyway, that's what I recommend. And if we need to modify it because we don't have enough data points, that's fine. And 5 data points is plenty. All right, so now let's go take our second data point. So I'm going to advance through the video frame by frame until I see that the clock stopwatch reads 0.2. So getting halfway, and there we go. All right, now where is the ball? I look carefully, and to me it looks like the ball is, boy, the front edge looks like it's just touching the 5 centimeter mark. But maybe it's 4.9. I'm going to say 4.9. 4.9 centimeters. Okay, now we're ready to take our next data point. So you can see this is going to go pretty fast, which is nice. Oh, went too far. All right, now I look closely. You can hear me getting closer to, see. That's going to be, I'm estimating to the nearest 10th. So I'm going to say 9.4, 9.3, 9.4. Yes, you're estimating. I'm estimating. All right, move on to the next data point. Go advanced. Wait, am I going? Yeah, 0.6. There we go. Where's the ball? To the nearest 10th of a centimeter. And it looks to me like it's right at the 14. I'm going to go 14.0. I'm looking at the right edge as a reminder. 14.0. One more. So we're going to go to 0.8. Actually, I have plenty of time. I could go to 1 second if I want, or even more. All right, it looks to me like, yes, to the nearest 10th of a centimeter. Oh boy, let's see. Yeah, this is the one you got to kind of go, So 18.8 centimeters. 18.8 centimeters. All right, so this is for the white ball. That's enough. Now, if you want to add more, well, all right, let's do one more. No, to save the time on the video, because you can always add more data points. Now it's time to get our graph. Now, why do I want to make a graph of this data? Because I want the slope. The slope is the velocity. So we're going to put position on the vertical axis. Now, so you click on configure vertical axis here and a pop-up box. Now you click on this and you're going to select position. Done. You don't do anything here. Now on the horizontal axis, click on that, and now we're going to put time. So we're looking for time. There it is. And now we see our data points. And they sure look like they line up in a pretty straight line, which is good. If you see one that's like way up or way down, it means you probably made a mistake and you want to go back and remeasure that. Now, I want to fit a line to my data points. So you click on this little gear thing and you go to curve fits, and I'm going to pick linear. Done. All right, now I think it already is at the 0, 0. I like to have it go right through, show through the origin, so I'm going to say include origin. I don't think that changed anything. All right, now what do I do now? Now, once you fit a line to the data, you look below and you'll see a little box, and you can see the equation, which looks like our position equation. Position equals A times T plus B. B we're going to ignore because it started at the origin. But look at that, A equals 23.3 centimeters per second. That is your velocity. That's the slope of this graph. And remember, the slope on a position versus time graph is velocity. So what is the velocity of the white ball? I'm going to make that here, and that's 23.3 centimeters per second. Okay, you're going to do exactly the same thing for the red ball and the blue ball, and then you'll have your velocities. That's how you get velocity from the video.